key upside down. Hey, how you doing? These are going to be the notes for today. I'm going to work off some of the same pages that we used in the last recording of the notes on imaginary numbers, and then I'm going to also work on page 1, 2, 3, 4, and 5. So we're just going to kind of flip around a little bit, okay? Here we go. Okay, just as a review from the other day, we'll go ahead and fill in a lot of this. So the imaginary number I is defined as the number whose square, if you square I, it is equal to -1, just like we talked about yesterday. There you go. I squared equals -1. And therefore, and we remember that I equals the square root of -1. So guys, don't forget that. Talked about that yesterday. So imaginary numbers can be combined with real numbers to make complex numbers. Okay? Complex number is any number in the form a plus bi or a minus bi, where I is imaginary. A and b are both, as you know, the real numbers. All right. Pause for a second. Now, we talked about all this yesterday in our notes. We talked about when you take the square root of a negative, you have to pull an I out, and then you have to simplify the square root of whatever this number is, x. So I can't remember if we did any of these problems the other day, but just as a quick review, the square root of 2 cannot be simplified, but I can pull an I out here. You can put the I behind the square root or in front of the square root. Okay, just don't put it under the square root. Then let's see. Let's look at number 5. Square root of 98 is the square root of -1 times the square root of 49 times the square root of 2. Okay, so we know this is I, we know this is 7, and we don't know what this is, so we leave it that way. So I'm going to start with my 7. Square root of 49 is 7. Square root of -1 is I. And then bring down the square root of 2 and leave it in the radical, because square root of 2 we can't simplify, okay? Again, I could put this I over here behind the radical if I wanted to. Here's an easy one. Square root of -9 is just 3i. Guys, these problems 2 through 6, 2, 3, 4, and 6. So basically, here I'll give you an example. We'll do number 4. We've got a regular 4, not a square root. Then we got a square root of -1, a square root of 25, and a square root of 2, because 25 times 2 is 50. Well, the 25 is going to cancel, and the square root of -1 is going to become I. So think about this. We got 4 times the square root of 25, which is 5, times the square root of -1, which is I, and then the square root of 2 I can't simplify. So my final answer over here is going to be 20i times the square root of 2, because I cannot break down the square root of 2. Okay? You can try the other ones and then ask me in class if you got them right, hopefully. We did these problems in the notes the other day, so you should have those. Can't remember if we did some of these. This is 11i. This is 10i. I just did one like this, so we'll leave that alone. This is -6i squared, which is -6 times -1, which is 6. I think I did that one the other day. We just talked about complex numbers when you combine a real and an imaginary number. You get a complex number, a plus or minus, bi. We'll just go with plus for now. You can add and subtract complex numbers, keep your real terms together and your imaginary parts together. So basically, I think what they want is you keep your real parts separate from your imaginary parts. Okay? Combine like terms. So we got negative 2 plus 1 is negative 1. And then we have 5i minus 7i is negative 2i. So keep your real parts and your imaginary parts separate because those aren't like terms, so that's your answer. Over here, think about distributing this negative 1 here because it's subtraction. So let's rewrite this problem. 4 plus 6i plus 1 minus 2i. So my real part is going to be 4 plus 1, which is 5. My imaginary part is going to be 6i minus 2i, which is positive 4i. So that's my answer. So that's addition. Turn the page over. Excuse me, that's addition and subtraction. When you multiply complex numbers, use the same method you're already familiar with. What methods are you familiar with? You might use the box method, you might use FOIL, or you might use double distributive. 3 different methods. Okay? Whichever method you use. Afterwards, you've got to make sure you combine like terms, and you got to make sure you replace I squared with negative 1. Okay? So don't forget to do that at the end of your problem. Okay, so I'm going to just do double distributive. Here's single distributive. And then when I go down here to the bottom and do 4i times everything, that'll be double distributive. So 2 times 9 is 18. 2i times negative 3i is negative 6i. 4i times 9 is 36i. And 4i times negative 3i is negative 12i squared, not I. All right? So I can combine the 2 i's in the middle, but I can't combine it with the I squared. So 18 plus 30i minus 12 times, not I squared anymore. We've got to change that to negative 1. 18 plus 30i plus 12. 18 plus 12 is 30, so my answer is 30 plus 30i. Keep the real part separate from the imaginary part because they're not like terms. Okay. Try this next one on the right. Try this one that my black pen is pointing at. So try this problem on your own. Pause the video. You should have gotten 27 plus 6i. If you didn't, ask me about that in class, okay? When I check notes, if I don't do a problem for you, people just don't do it. But I need you to try to do these problems and check it. That's why I told you to pause the video. All right. Guys, when you're dividing, your final answer cannot have I in the denominator. So we have to understand what a conjugate is. Now, the conjugate of I is just negative I. So negative I is the conjugate of I. Remember that. 1 minus 2i is the conjugate of 1 plus 2i. Okay? And 1 plus I is the conjugate of 1 minus I. So those are all conjugates, what I've written up there in red, okay? What we have to do is we have to look at the denominator, establish what the conjugate is, which I just did up there, and then we multiply the top and the bottom by the conjugate. So like this. Boom. And we'll multiply this out. Over here, we multiply down in the bottom by 1 minus 2i, the conjugate, and whatever we do to the top, bottom, we have to do to the top, so we have to multiply by 1 minus 2i. When you're working with fractions, you've got to multiply the top and bottom of the fraction by the same thing, or you change its value. You can never change the value of an expression when you're trying to simplify it. You're just rewriting it in a different form. So whatever we do to the bottom, we have to do to the top. You've known that about fractions for a long, long time. Maybe in class we'll talk about why 1/3 is equal to 2/6, okay, because you multiply the top and the bottom by the same number, which is 2. All right. So 2 plus 3i times negative I, that's going to be negative 2i minus 3i squared in the top. And in the bottom, this is just going to be negative I squared. Negative 2i, remember I squared is negative 1, minus 3 times negative 1 over negative, remember I squared is negative 1, there's a minus sign here, and then the negative 1 goes inside the parentheses, so there you go. Now let's clean it up. Negative 2i plus 3 over 1, which just equals, let's put it in complex number form, so let's put the real part first, 3, which is positive, and then minus 2i, which is negative. There we go. Okay? These next two are going to get a little bit more difficult because the conjugate is a binomial. Okay? I'm running out of time, so I'm going to say this. I'll go over a couple of these in class. Try one of these, either this one or this one. Try one on your own. Okay? It's going to be hard. Just suck it up and try it on your own. I'll go over both of them in class, okay? But I am going to write the answer to one of them real quick here. Hopefully you paused your video and worked out this problem right here. And you got 8 minus 16i over 5. Now, if you're using your calculator, it's probably going to give you 8 over 5 minus 16 over 5 times I. Okay? Those are the exact same answer. Okay? Now, actually, your calculator will probably give you decimals first, but then you can hit the button that says change it to a fraction. So anyway, these are the two answers. All right? So I have a minute and a half left, and what I'm going to do when you get to class is I'm going to go over a couple of these problems in here just for a review of the notes, a quick review of the notes, and you should already know how to add and subtract, multiply. I'm going to do this one right here real quick, okay? From Algebra 1, you should know how to factor dots, difference of two perfect squares. So this is just an old reminder, x plus 2 times x minus 2. Excuse me, x minus 2, not a. Okay? All right. You would have not learned how to factor this. This would be called prime. But the answer is x plus 2i times x minus 2i. We're going to multiply that out in class to prove to you that it equals x squared plus 4. Okay? And here's another one. X plus 6i times x minus 6i. Okay? So that should be it for the notes. I'm out of time. Thanks for flipping around from page to page with me. And thanks for doing your digital work. Remember, this counts as one of your bonus points for the week, so make sure you submit it. If you don't submit it online, bring it with you to class, but I prefer you submit it online.